Okay, today we are going to talk about logarithms and how that is related to our what power problems. If you were doing the worksheets day 1, 2, 3, you saw this what power function, and we gave you examples. What power 5 is 125? Well, that was 3. And what power 6 was 36? That's 2. And what power 2 is 1 over 32? Well, that was negative 5. And when you saw our answer keys, we said that was because 5 to the third power is 125. And because 6 squared is 36. And because 2 to the negative fifth is 1 over 32. This what power function actually has a much more complicated name. It is our logarithm, but as we like to do it with this what power idea because it seems to click better without this crazy word logarithm. So when we write log, we're actually, when we do what power 5 is 125, we're actually asking what is the log base 5 of 125, and that equals 3. And that is because 5 to the third power equals 125. So not only are we learning to evaluate logs with this what power function, by justifying our answer, we're learning how we can rewrite logs to exponential functions. They're inverses of each other. And so we can move back and forth between them, and that helps us solve them and solve equations that involves them as well. So what power 636 is actually asking us log base 6 of 36. That equals 2, and that is because 6 squared equals 36. This is the logarithmic form. This is a logarithmic form, and these are the exponential forms. And then the last one is the log base 2 of 1 over 32 equals negative 5, and that is because 2 to the negative fifth equals 1 over 32. So these two ideas are kind of intertwined with each other. How to evaluate a log, what it means, and rewriting it from an exponent to an exponential to a logarithm. So evaluating logs, okay, we look at the log base 3 of 1/9. And remember that log base 3 is just asking us what power. It's asking us 3 to what power equals 1/9, and that's the negative 2 power. And log base, how about 1/3 equals 3? That's 1/3 to what power would make it 3? That would be a negative 1 power. That's how you would get the reciprocal. And we can look at some other more complicated functions like the log base 5 of 25 to the x power. Well, 5 to what power gives us 25 to the x power? Well, that is going to give us 2x. Okay, because if we were to raise 5 to the 2x, well, we can't do 5 to the x, but we can do 5 squared, and that's where the 25 to the x comes from. So that's how we get that. And how about the log base 5 of 1/5 to the 3x? Well, we say 5 to what power would give us 1/5 to the 3x power? And that would be, that's like 5 to what gives us 1/5 to the 3x? Well, it's going to have the 3x, and in order to make it the reciprocal, it's going to have to be negative. So negative 3x would be that evaluating. And we can go the other way around. 2 to the log base 2 of 5. Well, this one's a little bit harder to explain, but the exponent is saying the log base 2 of 5. So 2 to some power, this power is going to make it equal to 5. So when I raise 2 to that power that makes it equal to 5, I'm going to get 5 back again. Also, the log base 2 and then 2 to the x are inverses of each other. So we just end up with x, and same with the other way around. 2 to the log base 2 of x is just x. Let's see. And then let's look at one more. How about the log base 2 of 1/8? And that equals -3. So we have a Quizlet you can do on evaluating logs. So that would be great practice for you. And instead of doing a worksheet, you can do that. And then I'll have some worksheet practices to put in there for you as well. Now the other thing we're going to talk about is rewriting logs to exponents and back. So if I want to go from a log to an exponential function, log base 4 of 16 equals 2. So again, we'll start with one that makes sense. Okay, in the end, if you get something that doesn't make sense, then you have to reevaluate that. So this is saying that 4 squared equals 16. And it's log base b of a equals x. And then it's b to the x equals a. And your book uses y instead of a. So let's look at another one. Log base 6 of 1/36 equals -2. So we rewrite that as 6 to the -2 power equals 1/36. And then we can get into rewriting expressions that have like variables in them. The log base 6 of 3x equals 4. Well, the base of the log is the base of the exponent, so 6. 6 is the base of my log, 6 is the base of my exponent. What it's equal to becomes my exponent, so 4, and that equals 3x. Let's color code that. Log base 6 of 3x equals 4. So the 4 goes there. And that kind of helps us see where all the numbers are going. So let's look at another one. Log base x. How about log base x of x plus 4? We're going to get a little crazy here. Equals 7. Okay, so just using the color coding here, the base of this log, even though it seems weird, why do we have x twice? It doesn't matter. The base of the log is x. So that's x. The exponent becomes 7. And then what it equals is what's inside the log, and that's x plus 4. Let's do a couple more. Log base 3 of x squared plus 1 equals, let's say 5. So we get 3, the exponent is the 5, equals 3 to the 5th equals the x squared plus 1. You're not expected to solve any of these yet, but this is going to be one of our strategies for solving logarithm and exponential equations. Okay, so now we're going to go from an exponent to a log, and we're going to try to use the same color coding. So it's log, so 3 to the 3rd power equals 27. So log, the base of the exponent is the base of my log, log base 3. What it's equal to goes inside the log. Log base 3 of 27 equals 3. So our numbers shouldn't be on the same side of the equal sign that they were with the old numbers. Let's look at another one. How about, let's get my colors right. 4 to the -2 equals 1/16. So that's log, the base of the log is 4, so log base 4 of what it's equal to goes inside the log, 1/16 equals the exponent -2. Okay, now let's throw in some variables, make it a little bit harder. So how about 2 to the x minus 3 equals 4. So to rewrite it, log base 2 of the exponent, or I'm sorry, of what it equals, log base 2 of 4 equals x minus 3. And we know what the log base 2 of 4 is, so we could actually solve that from there. So now let's see if we can do it without the colors. 5 to the third power equals x minus 1. So log base 5, the base of the exponent, base of my exponent, what it's equal to is what's inside my log, so of x minus 1 equals the exponent in the exponential 3. And the last thing we want to talk about is the natural log. We talked about the natural exponent e, right? Well, the natural log, ln, is the log base e. And it's used so much that they didn't want to write out all those extra 2 letters, so we write ln. Natural log comes from Latin. They put the word log first and then natural second. So the natural log of e is equal to 1, just like log base 2 of 2 equals 1 and log base 3 of 3 equals 1, because 3 to what power equals 3? It's 1. So whenever you see ln, you need to think log base e. So if I have ln of e to the x, that equals x. If I have ln of e to the 3x, that equals 3x, and so on. So if I have ln of e squared, that equals 2, because it's e to what power equals e squared? Well, the answer is 2. We'll talk about graphing these functions in a separate video. And the last thing we need to talk about is you just straight evaluating logs in the calculator. So if I have the log of 7 or the natural log of 9, you're just going to use your log button. Those ones are pretty clear. I'm going to add a little video in here for you. Okay, so here's my big graphing calculator. Works like most of your other calculators. Hit clear. If I want the log of 7, I just hit log 7, right? 0.845. Use 3 decimal places. And then my cell phone calculator, turn it on its side. We have, it goes backwards, so 7, and then we hit the log 10 button. No, we don't. Yeah, the log 10 button. Notice that there isn't a log base 3 and a log base 5 button. There's only the log 10 and the ln button. And the same thing in my graphing calculator here. There's only a log and an ln button. We don't have log base calculator keys for most calculators. So it's important that we are able to do the basic ones, because it's a lot more work to do them in a calculator when we don't have the key. And then the last, say I want the natural log of 9, I hit 9 ln, and then in this calculator I hit ln of 9. So you need to know which way your calculator goes. Does it go forward or backwards? All right, and the last thing we talk about in this chapter, or this section, is finding the inverse of the function. And to do that, we're just going to think about what we did last time. We switched the x and y's. And then instead of just solving for y, we're going to rewrite as an exponential or a log, the opposite, whatever it started as, the opposite of what it started as. And then we're going to get y by itself. So if our equation is, say, y equals 1.3 to the x power. Well, step 1 is switch the x and y. So x equals 1.3 to the y. And then we're going to do rewrite it as a log. So log the base of the exponent. Let's color code this like we did the base of the exponent, what it's equal to, and that. So we're going to go the other way here. The log base 1.3 of x equals 4. Oh, sorry, that's not 4. That's y. Equals y. And y is already by itself, so we're done. Let's do another one. Y equals, how about, let's do one with e to the 5x. So we're going to color code this when we rewrite it. 5x, oh no, I'm going to just switch the x and y, sorry. So x equals e, that's the base, to the 5y. We are rewriting it. We're switching the variables. Now we're going to rewrite it as log base e, but we don't write log base e. We write ln of the blue x equals the exponent 5y. And then y is not by itself yet, so we need to divide by the 5. So we can say y equals the natural log of x divided by 5, or we can write 1/5 natural log of x. Okay, let's do one where we have the log. Y equals 2 log base 3 of x. So we're going to first switch our x and y. So we get x equals 2 log base 3 of y. And we have to get the log base 3 by itself before we can rewrite it, so we have to subtract 2. So we end up with x minus 2 equals log base 3 of y. And then if we rewrite that, we get 3 to the exponent, x minus 2, equals the y. And y is by itself already, so that's our inverse. That's a more complicated one. So it's all about this rewriting the exponent and then getting y by itself.